Good evening, everybody. So, the project title is Mobile Infrastructure for Coastal Region, Offshore Communication and Networks. The parallel is Amrita, IASP and YTMK. So, this is the team, and we have from Amrita the lead, and also the co-PIs, Professor Sedu, is here, and Balaji and Dr. Venkata, Dr. Sridevi. And co-PIs, we have Dr. Manish from IASP, and Dr. Elizabeth Shirley from Indian Institute of Information Technology and Management. And we have the offices members, we have Dr. Nitin Vaidya, Dr. Prashant Mahapatra, Dr. Sajata, and Dr. Cheshaya Pannakandi. A lot of other information which I am skipping. So basically, in this project, the central aim is to provide a mobile infrastructure for coastal regions of India to enable offshore communication. So why this problem is majorly in the fishermen community, what is happening is when they try to go for fishing, they have to actually travel about 120 kilometers and they are in the sea for 5 to 15 days. And during this time, what is happening is the current technologies are offering the communication to the shore from the shore up to only 15 kilometers. So that means in few hours they leave the shore. We don't know where they are and how it is happening with the boat and anything. So the community, the fisherman community, which is more than 4 million people, are actually always in trouble, thinking that where is my family member, where is the boat, what happened. Till they come back, they don't know where I am, and the families are still waiting for. There are a lot of people who have gone for fishing and has not come back for years. So that's why the project is trying to look into coming up an extensible and adaptable communication and connectivity. And as part of that, we are also bringing in the education and research component, which will help the students to learn the different technologies also. So the overall approach was, it majorly involved the user requirement collection, which helped us to actually look into the evaluation of existing techniques, and based on that, we have come up with a design a scalable and affordable architecture. And to do in all these processes, we also have looked into the modeling of virus propagation and coming up with high gain directional antenna development. And to build the network, naturally look into the network simulation and development of network protocols, develop and deploy the real-world test bed. And with all these things, whatever the real-time data come in, we have looked into the data analysis, visualization, and to involve the community along with the whole process. There is the mobile apps which are helping them to involve and get the information what we are providing. Integrated the educational programs and advanced laboratories which is required for the whole. So what is the major achievement within these 3 years is we were able to launch the whole system in the last September 2016 by the Honorable Central Minister for HRD, Mr. Prakash Javadekar, and in the presence of Kerala Minister of Offshore Fisheries and Harbour Engineering, Mr. J. Merchikutiyamma, and the former Chief Minister, the presence of our Chancellor. And during this launch, we were able to have 4 trawlers in the sea communicate to the Minister using Skype video call from 48 kilometers away. That means 15 has been extended to 48, and our current sea drives has gone up to 60 kilometers, more than 60 kilometers. And the boats were real-time monitored and tracked. So these were the different news which came out. A quick video we will show. to bringing this whole solution, there was a lot of complexity in developing. One of the major complexities which we had to face was there was no existing affordable solution to solve this problem because we needed a long range communication. At the same time, the terrain is so unknown because most of the work has been done by either the Navy or any of the defense related people. So they don't actually bring out the results which they have. So the ocean parameters and the propagation effects were lacking there. And the coming up with a system, there was a lot of things which are involving was there was seasick variation, extreme mobility of modes, and there was no existing studies of fishing boat mobility. Long range coverage requirement was there, and there was spatial temporal variability of density of boats. Mobility pattern variability and data rate variability has to be incorporated in bringing in the whole thing. So we needed a communication technology that can cover fishing in the ocean other than satellite network because it has to be low cost for this fishermen to use. So we had to use multi-level heterogeneous nodes which can give us maximum transmission. And to get long range communication, we also have looked into the direction array antenna arrays for long range transmission, antenna arrays for better signal strength and adaptive beamforming for more coverage. And with hybrid networking has been incorporated to achieve the connectivity assurance and also the localization of fishing vessels.
I have a question.
Yes.
You're not looking at this as an ad hoc network?
It has both the architecture as well as reaching to the architecture. So with all that, it has been connected to the network operating system, providing the required information system. So if I say the architecture, in the architecture, one of the major things which we have learned from the fishermen communities, most of the time they go as a cluster. They have actually friend boat groups. That's what they do. And when they go in, based on where the fish population is, they group there. And then they do the fishing, and then if it finishes, they move to the next places. So what we have approached here is, we have a multi-hierarchical network with multi-point, where you have the base station on the shore, which is connected through these boats. So the boats itself has been categorized as three different things. One is super node, adaptive node, and active node. Where the super node has adaptive backhaul equipment, which are directional antennas, which will connect to the base station, and also at the same time they can act as mobile base stations, which will provide extended communication services. And we have adaptive nodes which have only one adaptive backhaul network, so that means they can either connect to the base station over to another super node or an adaptive node to extend it. That's what they have the case. And access nodes are the nodes which have only routers, and that our mobile devices can basically connect to these access routers. So this multi-level approach will help you. So in any cluster, you will have multiple of these things, and based on their availability, the connectivity variation. That's how the architecture has been set up at this point.
Manets is ruled out. Ad hoc network technology is ruled out.
Because it cannot be completely ad hoc.
So the ad hocness comes in the mesh network. It's an ad hoc mesh within a cluster. That's the ad hoc part. Rest of it is infrastructure.
It's a hybrid.
It's hybrid.
Can I move? So all this has been connected to the network operations center, where it will have the connectivity management, network management, security management, and the different application and services, which includes weather alerts, e-commerce, obstacle inclusion, localization and tracking, early warning of collision avoidance, and data dissemination review. So with this background, the research contribution I would say is there is designed and implemented the unique architecture for extended offshore connectivity by integrating heterogeneous networking techniques. And the other major thing is to get the extended one. We have looked into the design of new antenna system, where we brought in-house RF front end for long-range Wi-Fi, high-gain low periodic antennas, metamaterial antennas, and butler metrics for phased array system. We have developed for the mesh net, we have developed the software-defined networking framework, which include the wireless mesh network with open flow controller, designed and tested the hierarchical SDN framework, and an efficient lightweight DTN protocol has been designed for this. Along with that, we have looked into the design of the connectivity management strategies, network management, and security management. With all these things, on the other side, everything has to be connected to the fisherman community, so it naturally needs the applications and services. So design disaster management framework, completed learning and pattern recognition for real-time mobility data of fishing vessels, real-time localization and tracking, intrusion alert system, real-time vessel pollution and detection, fish market analysis. All these things, as of now, the whole group has 68 publications and 3 patents has been filed. With respect to the engineering solution, we have developed an adaptive, demand-driven and energy-efficient first-level point-to-multipoint backbone network, and we have tested it with both 5 GHz and 2.2 GHz here. And a permanent deployment for the system in 10 crawlers have been done, where 2 has been completely done and 8 are in progressing, which will finish by the July end. That's where it is. That's when because now in Kerala it is the ban period, June to July. That period you cannot do anything, you cannot take it out. So, and on top of that, since these are directional antennas, you need to have an antenna reorientation. So initially we worked with remote controlled rotary platforms, and those were deployed in the system. And after that, we have actually designed, prototype and tested in-house built, fully automatic antenna orientation system. So which has been integrated into this board. So they don't have to change now. And real-time monitoring and tracking using mobile app, where it will be duration, distance, where it is, how it is, which is the nearest node, etc.
So the antenna reorientation is mechanically you are doing, electronically you are not
Electronically.
steering the antenna?
So initially we done with the mechanical setup where we use the remote. That's the first pilot one.
Yeah.
But so which gave us like a two year time to work on that, and then we made ours. And so this is what you will see, that you will have an antenna system on the back. This is the base station, which is about kept at a height of 56 meters, which is on the top of a building. And on the board you have about 9 meters this one, and you have the equipment on top of it. You can see this. This is the nano station which will communicate with the base station, and you have the. So if you see that, so earlier I was talking about super node. So you have the equipment, the adaptive backward network equipment is there. Then the router is there, which will help us to achieve the connectivity, and the devices will be able to communicate with us. Same way with the adaptive node also. And this is the antenna rotator which is deployed on the fishing vessel. So I'm not going into detail how we have implemented and all that. So as of now, we have actually done 6 sea trials with 14 trawlers, and where we have spent almost like 108 hours in sea. This is what 6 sea trials which you can see. And up to a rest of Douglas Sea State as 4 to 5. We completed testing with 5 GHz and 2.5 GHz. Totally a maximum range of more than 60 km has achieved, where first hope becomes nearly 50 km. Second hope, which is the board-to-board communication, which is maximum 20 km, and performs Skype call, video call, WhatsApp, internet browsing, YouTube, etc.
So are you using some kind of a Wi-Fi protocol?
Long range Wi-Fi we are using. Long range Wi-Fi. So it has multiple long range Wi-Fi and the normal Wi-Fi. So both the technologies together we are using.
So you are using basically hybrid TDMA and CSM?
Yes.
And these are the test results.
So how fast are these boats moving?
They are actually, their maximum speed is between, like, it comes like 12 km, I would say. The lowest speed is about 5 km.
Per hour.
But they are not moving all the time, right? I mean, they're sort of usually
Yeah.
anchored at some point.
They will do the fishing.
Of the 10 days or whatever they are in the sea, if they just go somewhere, fish, go to another place, fish, and then eventually they collect it back. Am I right?
Yeah, yes. So when they are in the fishing place, it's just like in this room, like they just roam around like a random, they just roam around.
Or within a small area?
Within a small
Okay.
area of 5 km or 3 km, they'll roam around. But to reach that place, they'll have a straight path which they are.
So this fish is better than the fish in Bengal. I didn't train any hackers. So.
What do you know about?
George, am I right?
Yes. These are the different sea trial results.
That's
And
right.
to achieve all these things, we have actually looked into link level simulation and optimization of hierarchical point to multi-point backward and validated the architecture and prototype. Anywhere you feel like me to stop, I will stop. But I'm just now going fast because you told the time is only that much. So we have looked into the performance and scaling of test, automatic reorientation and impact of motion effects. We also have
What's the
looked
impact
into
of motion again?
impacts of motion effects on the Wi-Fi.
Things like pitching and rolling, all that. So in fact,
is
two
there
of
a
our-
second presentation? This is it.
This is it. This one presentation, I am trying to present the whole thing as fast as possible.
If you make 4 presentations, then it tells me there is no collaboration between the 4 teams. If you make one presentation that tells me all the teams are collaborating.
Yeah, you will understand. So we we also have looked into with the, in real-time data what are the maximum pitch and roll we are saying. Based on that, how is its impact, and we tested this and then looked into the antenna how we have and looked into how the signal strength is variation with respect to forward pitching, backward pitching, roll towards left and right. So how is it impacting and where it has to be corrected? Those data has been. And another thing was how do you optimize the wireless multi-backward link selection in this trial time, because as I said that there are different clusters. In the clusters, how do you make sure that you have good connectivity with the base station with respect to the signal strength, and how do you make sure that you have lesser packet drop? So that is where the optimization works. This was actually collaborative work between IISc and Amazon, where we worked together. These are the different results, how it actually selected different access routers and things like that. Then with respect to the antennas,
Both these things were actually presented at the MobiHawk 2017 by our students a couple of days ago at IIT Madras.
and then we have actually very extensive work on the development testing of antenna solutions have been done.
So you did the research, you did the development, did you also do the fabrication and
Part of the subsystem fabrication we have done, part is still working on. So the one part of it is the actually whatever the off-the-shelf component which we bought. The second part is as
So
I
are there off-the-shelf systems that are deployed?
off-the-shelf long-range Wi-Fi system we have bought, and initially we have controlled those systems. And also as I said that
So cost-wise, what will it take for me to build a system for 14 homes, 3 clusters? 14
so basically
homes?
it's like the nano, the base station is the highest cost one, which is the total cost is
14 boards and
14 boards split into 3 clusters, communicating with the base station on the shore.
okay. So let's say about $200 per board. So we're talking about say $3,000 to $3,500.
Per board.
No, total
$100. Dollars or rupees?
dollars. Sorry?
It's pretty cheap.
Yeah, that was the goal. We want to keep it cheap. It should be almost no cost to the end user. They are fishermen.
That's why they want to adopt it.
no. It's not even 4, sir. It's not even 4. You said up to 450.
He said 14.
So we have worked on high gain antennas for the this is for the equipment in the board, where we have used coplanar antennas, and high gain antennas for base station, where we have used the low periodic antenna and metamaterial antennas have been used. These are the different fabrications which we have done, and based on that we have optimized it, and what we have done is we got up to a gain of 12 dBi and a range of 70 km in the board, where when you want to do the board-to-board communication, that
What's your-
inside a cluster.
What's the beam width for this 20 gig?
What's the beam width?
We can actually it will be
How many sectors here?
yeah, decrease it will be somewhere around 18, 19 degrees. Or you can. The thing is, we initially started without OLRs, and then we initially the antenna system had only 6 dBi gain. So we have modified it to come up to 12 dBi gain.
17, 18
Because
you can get much larger,
yeah, that
you can get much larger than 5
yeah,
dB.
but the thing is, the substrate we used was a longer substrate, so the loss was there more. So since we adopted for this locker system
Okay,
also,
okay.
that is.
Makes sense.
And I will, for the antenna part, I will add on for the base station. This was the antenna which we had purchased, and we replaced that. There, it was also a 12-element array antenna. We replaced it with our antenna. What we were able to achieve is we integrated it into the system, and it was compact as well as we were able to achieve more power level for our
What are
antennas.
those two pictures? There was some rocket and something else?
Yeah, that is
Those
which
are
we have commercially purchased. That we have replaced with what we have fabricated. So we were able to achieve a higher power level for the antennas that we have developed. So at least we can say at least a 3 dB increase in power is there, means a smaller increase will be there. I want to add on that the work has been appreciated by in national level by giving up. There was a best project award for this by ANSYS HFSS team. Then it also got one best paper award and one best poster award also.
There are byproducts also from that work.
What was that, ma'am?
Actually, okay.
Never mind.
Want to know? One is we made a sensor, microfluid sensor for detecting glucose sugar level. Second was reduce. Usually there is radiation hazards from an antenna. So how effectively we can reduce the radiation towards the user. So first one on the left side is the antenna where you have that radiation coming through that plant. Second is with that reduced using the OLR network, how we were able to reduce that.
So this is a work actually by the IASP group. Actually, they have actually done the indoor and outdoor implementation testing of SDN solution, where they brought in the wireless mesh network with the open flow controller for Micronet, hierarchical SDN framework, and efficient lightweight VPN protocol stacking for messaging over Micronet. So they have made Mesh 2.0 an open flow based wireless mesh network framework, and which has been developed and tested and integrated. This is the architectures, and with respect to the hierarchical, they have in the hierarchical test bed, why they were looking into it is majorly because we need a cluster-based mobility of nodes, and which forms a hierarchy structure. So multi-level control decisions was involved. So they integrated the hierarchical approach to the SDN control plane in a feasible manner. Different mobility patterns were looked into it, and based on that, the approach has been integrated at multiple levels and tested. And they also have built a scaled experimental test bed for this, and also an efficient lightweight VPN protocol for this also has been developed and tested with respect to that. And to understand also the mobility of the whole board, real-time mobility has been collected from 19 fishing.
In 4:15, I walk out of this room.
Yeah.
Just to
Finishing.
say that I must give 5 to 7
Yes,
minutes
yes.
for commentary by members.
So we made the mathematical border, tracking and location, and we also have made the Micronet information management and the visual front.
Time will set this by 5 minutes video.
No, why don't we just play that at the end? You can ask questions now and we can play that at the end.
Yeah.
So what we have done is this from a data discrimination from the systems, we have developed a web portal that is known as information management system. And we have also developed a Android application that we call it as a Fisher friend. So this is the architecture of our mobile application as well as our web application. There what we do is that we provide various services to the fishermen and the community. There are various stakeholders involved in this project. We have board owners, Navy, Coast Guard, government, etc. And these are some of the developments that we have done it, because in order to improve the productivity of the fishermen, so we have done some research on increasing the fish catch. So what it does is that there is a term called potential fishing. So that is an area where the fish catch is available. So we have found out the potential fishing zone area where fishermen can go directly to that area and they can take the catch from there. And we have also analyzed what type of fishes they have put it and the volume of the fishes, so that it is possible for an online marketing. So these are the various services and relevance to the project. It provides a disaster management system. So we have something like a missing board identification system, decision support system, critical information dissemination, and we also put even in the cluster that Anisha ma'am has discussed, we will be able to find out the maximum signal strength available in node, and if any node, if the connectivity is not available, they will be able to find out the weak other connections available, and they will be able to communicate within the clusters. And ocean state forecast, the weather details, this all kind of things it will be able to provide. And this is one of the things that happens very often. There's collisions of the ships and the boat and the boat collisions, etc. But we have done is that in order to avoid the collision, in fact, we will be able to find out which object it is coming. So if it is not in labeled one, so if it is a foreign vessel, we will be able to identify that vessel, and we can give the alert to the things, and boundary crossing, that is international boundary crossing, is also able to identify if any foreign vessels come from within this area. We could be able to give the alert. And fish catch, volume I already mentioned it, and the various messaging systems is also incorporated in the system.
I think we need to conclude. I mean, you can be sure that there is great appreciation for this project, particularly from the fact that when Professor Pooja started to talk about some of the successes in the project, our project was the first one that we talked about. So I think there is fair amount of appreciation for the effort that has gone into the project. So let me request you to stop at this point in time and give an opportunity to grand members to ask a question or two if they have side.
I think this is one project where you can see the societal impact very clearly. Also, I mean, there are incentives for the fishermen as well to use it. So I think, again, this is one of those projects which I would highly recommend to be continued further. I mean, there are very few bottlenecks in how to make it mainstream. So I think that's a very good aspect of this particular project.
Yeah, I also think that this project, because it has been piloted so well, it's already worked on the field. Either pick up a funding entity like some other department of the government which has to fund it, probably the fisheries department or
But first, this university and this organization backing the university, what is your rollout plan?
So currently, what we wanted is this 10 whatever we are deploying, we wanted to take forward, and we already had discussions with the Kerala Ministry of Fisheries. And they are also waiting for these results to come. They wanted to take it forward as well. And with respect to the entrepreneurship thing, because Rahuja is actually pushing us, and we are still like, okay, let us operationalize.
So yeah, I was waiting for this. So, so tell me one person who we can call whenever we want, whether you are in the US or not, we should get definitely, because otherwise we will be just not doing anything. This is so important. So I know you realize this, but you have to make it better. Tell us one point of contact who we can actually work with so that we can push it forward together.
Do you want it like a technical person or is it like a
Somebody who from your team can make it happen.
Why not one or two or three ladies who made
We are just discussing. For me, like, I wanted to see the 10 boats completely running, everything pakka. It was super.
No, we can parallelize.
Yeah.
So I think this has to go to 10,000 sooner or later.
Yeah.
And not just Kerala.
Yeah, Tamil Nadu has already come to us actually.
So you can even give it to Elizabeth or say to whoever it is or you. But then
I think Indian government should take this project.
but
Indian government should take it.
but they have to be
ये बड़ा विचित्र अप्रोच है कुछ करके सब कुछ गवर्नमेंट की तरफ ये तो बता दो कि क्या लगेगा क्या मिलेगा मिनिस्ट्री ऑफ ओशन
मछली मिलेगा मछली मिलेगा और क्या चाहिए आपको बिना का मछली मिलेगा
at least this buzzword should go up government whenever you feel doubts government should take over fisheries तो major department issue is now that technical proof of concept is done. Yes, sir. To roll out, what is the business plan? What is the cost angle? Where do you need the subsidy? To what extent? How much farmers, fishermen can pay? Somebody has to do the job. I think everything is a permanent equipment. On average, 10-year average cost will come down. Once you deploy, it is a permanent.
Government is not necessarily in deployment, but in organizing these things, government has to be
They
involved.
have to tell what is all is required and where is the public intervention which can come and where the government should intervene.
I think that's a
Somebody
I think a bigger plan, not
diligence
necessarily
and
the rollout plan has to be prepared with larger implications and so on. So there's actually quite a bit to
So, one comment I had, it's kind of hard to test. How does it work under the adverse weather conditions like storms? Obviously, you're not testing
No,
that.
no, I think that is exactly what they want to use it for. In the sense that
But what if
adverse situation is something that
As of now, our testing has gone up to the scale of 5, the Douglas. This is
stage condition up to stage 5 we have tested.
How many, what is the size of the scale? I mean, how long does it go? No, what is the size of the scale? Scale 5, what is after 5?
After 5 how much it is? 5 we have done.
0 to 9 is the classification.
0 to 9 is the that's what I want.
That's the severity, weather severity, say,
Yeah.
up to state of 5.
How rough the seas are.
Yeah, 5. That's a medium level.
9 would be what? Example of a 9 is a tsunami or anything less than that?
It is slightly less than that. What slide? Basically,
Yeah, I think I'm being hard to
Okay. You have any questions?
So is that?
Yeah, I want to go.
How many kilometers normally people go?
People go up to maximum of 120 kilometers, it's like a boat.
It's one of the flagship projects of ITRA, but success has to come.
Yeah, we need support to make it happen.
We do have operational difficulties that we.
You have divine support. What more do you want? सरकार क्या करेगा? है ना सर? ठीक बोला?
Thank you very much.
Most dangerous of professions ever is once